Example, find an integrating factor for this differential equation and solve the equation. So the given differential equation is of the form m dx plus n dy is equal to 0. So compare with m dx plus n dy is equal to 0, we have m is 2xy cube, n is this. And then find dA by m by dA by y is this 6xy square, and dA by n by dA by x is this 6xy square plus 2xy cube. DA by n by dA by y means the derivative with respect to y, means x is constant, keep x is constant. So derivative of dA by n by dA by y is 3x square is constant, y square is 2y, and x square is constant, y cube is 3y square. So we have this derivative dA by n by dA by x, not with respect to y, with respect to x. So 3y square is constant, derivative of x square is 2x. So we have 6xy square. Now this is 2xy cube. So this is the dA by nx. Nx means dA by n by dA by x, and m suffix y means dA by m by dA by y. And we observe it right here separately. DA by m by dA by y means my and nx. And then see, it is these two are not equal. This is dA by m by dA by y, and this is dA by n by dA by x. These two are not equal. So the given differential equation is not exact. So this type is what? This is the example of the type. The given differential equation is not exact differential equation, but we can reduce it to exact by finding integrating factor. So now we have to find the integrating factor for this differential equation, because this differential equation is not exact differential equation, but we have to reduce this differential equation to exact differential equation by multiplying the given differential equation by integrating factor. And now there are in all 6 types of integrating factor. First is introspection method, and the remaining are 9 rules, 5 rules. Okay, so out of that we have to use one rule. So here if you find my minus nx is this, and if you find my minus nx divided by n, then this is, we have this answer. And is not the function is not independent of y, means this is not a function of x purely. This is not function of x. This is not fx as a function of x alone. This is not independent of it. This is function of mixed type, x and y, as well as x as well as y. But if this quantity is a function of y, a function of x alone, then we have to find the integrating factor by using e raised to integration fx dx. But this is not function of x alone, which is not independent of y, means what? This is not the function of x alone. And so that rule fails for this example. So we find nx minus my, means dA by n by dA by x minus dA by m by dA by y divided by m. Now nx minus my is plus 2 times xy cube divided by m is 2xy cube is 1, and is independent of x, or if you have this value is equal to function of y alone, that is purely function of y independent of x, then e raised to integration of this fy dy, suppose this denoted by fy, then e raised to integration fy dy is its integrating factor. So this is one of the rule to find the integrating factor. So to find the integrating factor, in all there are 6 methods, 5 rules, and 1 method is the integrating factor by instruction method. So at the beginning of this topic, we observe these 6 methods. This is the instruction method. We have to use these formulas to obtain the integrating factor. And the second, in the second method, the rule number 1, 2, 3, 4, 5. These are the 5 rules. So in this rule, in these rules, if dA by m by dA by y means my in another notation, m suffix y minus dA by n by dA by x divided by n is function of x alone, then e raised to integration fx dx, or if it is equal to not function of x alone, but it is a function, it is constant. Suppose this ratio is constant c, then e raised to c dx, that is denote this value equal to fx, and then e raised to integration fx dx is its integrating factor. Okay, so this is equal to fx as a function of x alone, purely function of x independent of y, then we will find integrating factor by this method. But if what is the difference between these two ratio? It is dA by m by dA by y, it is minus dA by n by dA by x, and this is what? dA by n by dA by x first, then minus dA by m by dA by y divided by m. Instead of divided by m, we divide by m. And if it is function of y alone or it is constant, this ratio is a function of y alone, means free from x. This is the value of this quantity is free from x. Then integrating factor is e raised to fy dy or e raised to integration cy c dy. Okay, if it is value is c. So this is the rule. Now the example, the current example is on the rule number 4. That is dab n by dab x minus dab m by dab y divided by m is, we have the value is constant. So in order to obtain the integrating factor, use uh, either that one rule out of that 5 rules, or use the instruction method to obtain the integrating factor. So here we have dab n by dab x minus dab m by dab y divided by m is constant quantity. And so suppose it is qy, suppose we denote this function as qy, we have the value of this ratio is either constant or function of y purely. So we denote it is it equal to fy. And so e raised to integration fy dy is integrating factor. So write I dot f dot is equal to e raised to integration fy dy. That is fy is 1, so its integration is y. So e raised to y is the integrating factor. Or here this is the PDF of another book. So there is some difference between notation. So this instead of this one denoting by q fy, here the notation is qy. This one is, this ratio is denoted by qy, and integration of qy is separately finded here. That is integration of 1 dy is y, and then integrating factor is denoted by mu. No need of notation. We write directly integrating factor is equal to e raised to integration qy dy, that is y. So it is integrating factor. So multiplying by e raised to y to the given differential equation, we have this differential equation. And then this is an exact differential equation. So multiplying by e raised to y in bracket, so we have this, and this is the exact differential equation, because the given differential equation is not exact, but e raised to y is the integrating factor. And we know that the definition of integrating factor is what? Integrating factor is the factor or function in a function such that if we multiply by that function to the given differential equation, which is not exact, reduced to the exact differential equation. So this is the exact differential equation. So its solution is integration m dx plus integration terms in n independent of x dy is equal to constant, and that is 2xy cube e raised to y dx. This is m, and the terms in n independent of x, this term is depend on x, this term depend on x. So e raised to y is the only term which is independent of x or free from x. So e raised to y dy is equal to constant. Now integration is with respect to x, means y is constant. So 2y cube e raised to y is constant quantity. Just find integration of x dx plus e raised to y dy, integration e raised to y dy is equal to constant. And so integration of x is x square by 2, e raised to y integration is e raised to y. And so cancel these two, we have this, take e raised to y as common. So this is an implicit solution or general solution of the given differential equation. I can, the same type problem, find an integrating factor for this and solve. So m is this, n is this, and if you find dab m by dab y is 5x plus 2 with respect to y derivative, and with respect to x derivative of n, dab n by dab x, that is nx is 2, and these two are not equal, and therefore the given differential equation is not exact. Now we have to find the integrating factor. So there are in all 6 methods to find integrating factor, the inspection method and the remaining 5 rules. So we find my minus nx is 5x, my minus nx is 5x, and my minus nx divided by n is 5x by 2x is 5 by 2. And this is independent of y, it's purely function of y. And so we denote this is by, this is by 5 by 2, this ratio by fx. When we denote by fy, the given the ratio, if we would consider nx minus my divided by m, then we denote it by fy. That is the function of y. But if we find mx minus my minus nx divided by n, then we denote it by fx, if it is a function of x alone. So when we denote by fx and when we denote by fy, We note if you divide by n, divided by my minus nx divided by n is the ratio, then we denote it by fx. And if the ratio is nx minus my divided by m, then we want it is equal as a function of y alone, and we denote by fy. So in this case, we denote this by fx. So this is the PDF of another book. So instead of fx, the notation is qx. So qx is 5 by 2. Then find integration of qx, as integration of 5 by 2 with respect to x is 5x by 2. And so integrating factor is what? E raised to integration fx dx. That is integration px dx. That is 5x by 2 is the integrating factor. So write it denote by mu x, or just say mu, or write I dot f dot integrating factor e raised to 5x by 2. So multiplying the given equation by integrating factor by this e raised to 5 by 2x, this differential equation. So we have this multiplying the given differential equation by e raised to 5x by 2, and this is now an exact differential equation. So yields the exact differential. This is the exact differential equation. After multiplication of integrating factor, the non-exact differential equation reduced to the exact differential equation. And now its solution is integration m dx plus integration terms in an independent of x dy is equal to constant. So write m as it is. So that this is the m dx plus terms in an independent of x. There is no only one term which depend on x. So 0 dy is equal to constant. And so we do not we multiply this e raised to 5x by 2 in bracket. We have this. Then 5y, this take 5y as common outside the integration, because it is constant. Integration is with respect to x. So 5y integration x into e raised to 5 by 2x dx. This is the first factor. Then plus 2y is now constant. Integration e raised to 5x by 2 dx plus 5 is constant. E raised to integration e raised to 5 by 2 x dx is equal to c. So split in the three parts, three integration. So sum of as this three integration. Then 5y, and this is the integration by using part rule. So x is first, exponential function is second. So first integration of second, e raised to 5x by 2, 5 by 2x is e raised to 5 by 2x divided by 5 by 2. So this is the rule. E raised to x plus b, integration of e raised to x plus b dx is what? E raised to x plus b divided by a plus constant. And minus, again the integration is minus part rule. First integration of second minus in integration minus this integration of second e raised to 5 by 2 x. Its integration is e raised to 5 by 2 x divided by 5 by 2 into derivative of first, that is 1 x, derivative of x is 1 dx. So this is the part rule. So what is the part rule? Integration of first into second is first integration of second minus integration of second into derivative of first. So plus 2y e raised to 5 by 2x integration is this. Again the same e raised to 5 by 2x integration is this is equal to constant. And then write this divided by 5 by 2 means into 2 by 5, right outside the integration 2 by 5. And then e raised to integration of e raised to 5 by 2x is e raised to 5 by 2x divided by 5 by 2. Its integration plus simplification of this as 2 by divided by 5 by 2 means multiply 2 by 5. So here also 2 by 5, we have 2 by 5 get cancelled, so we have 2. And then multiply this 5y in bracket, we have this. This is 2 by 5 into 2 by 5 become 2 by 4 by 25, but after multiplication we have again 4 by 5y e raised to 5 by 2x plus similarly these two terms, and then this term get cancelled, plus minus. So we have, this is the final answer, 2y x e raised to 5 by 2x plus 2 e raised to 5 by 2x is equal to constant. And this is the general solution of the given differential equation. So again the same type problem, find an integrating factor and solve the equation. So this is m dx plus n dy is equal to 0 type problem. So m is this, n is this. Then find dA by m by dA by y, means derivative with respect to y is 12xy plus 2. And dA by n by dA by x is 24xy plus 6 is the dA by, nx, dA by n by dA by x means nx. Okay, derivative with respect to x means y is constant. And these two are not equal. And now we have to use the we have to find the integrating factor by using one of the rule. And then my minus nx is what? Is minus 12x, that's subtraction. So minus 12x minus 4, subtraction. 12xy minus 24xy becomes minus 12xy. 2 minus 6 become minus 4. And if you find nx minus my, then it is plus 12x plus 4. And so the given differential equation is not exact. And then my minus nx divided by m. If it is a function of x alone, then we say e raised to integration fx dx is, suppose this value is equal to fx, then that is the function of x alone, then e raised to integration fx dx is integrating factor. But my minus nx divided by n is this, and this is not the function of x alone, which is not independent of y. It is a mixed type function. It is function of x as well as y. It is not purely function of x or independent of y, and therefore we find instead of my minus nx, right, nx minus my divided by m. Nx minus my divided by m. So nx minus my is this plus 12xy plus 4 divided by m is this 6xy square plus 2y. Then take 2 common from numerator, 6 common, y common from denominator. So with this bracket are same and cancel. We have 2 by y, and which is independent of x, or this we have is a function of y alone. Y alone. It is not mixed function of x as well as y. It is a function of x, y alone, and therefore it denoted by qy. So comparatively study these two rules. So either this is function of x alone, or this is function of y alone. What we want, either this is function of y alone, x alone, or this quantity as a function of y alone. If it is, this is function of x alone, or this is function of y alone, then these rules are applicable. If what happen if like this mi minus nx divided by n, what do we have? It is a mixed function x as well as y. And if you have suppose nx minus my divided by m is again the function of x as well as y, then these two rules are not applicable. So in that case, how we can find integrating factor? We can find integrating factor by some another rule, because there are in all 6 methods. So not only these 2 methods are obtain the integrating factor. There are in all 6 methods. So we have to obtain the one method out of the 6 method, appropriate method out of the 6 method. So this is the applicable now. We have this ratio is equal to function of y alone. So denote this as fy or qy. Yeah, we can use any notation. And then e raised to integration fy dy is integrating factor. So we denote here, we denote it by qy, 2 by y, and integration of qy is 2 by y means 2 is constant, log y, 1 by y integration, and 2 log y is log y square. So integrating factor denoted by mu or mu x or any notation. It is not actually mu x, mu y. So don't write this mu x or mu y as the notation. Write just I dot f dot integrating factor is e raised to integration qy dy, that is e raised to log y square. E and exponential function and logarithmic function are reciprocal inverses of each other, and therefore they get cancelled. And so we have y square as the integrating factor. So multiplying the given differential equation by y square, this differential equation, so multiply by y square, we have this. And after simplification, multiply by y square to bracket, we have this. And this is exact differential equation. So its solution is what? Integration m dx plus integration terms in n independent of x dy is equal to constant. So write m as this. Then write terms in n independent of x. This term is depend on x. This term depend on x. This term is not depend on x. So 3y square dy is equal to 0. In all, there are 3 terms in n, but these first two terms depend on x. And so we take only this 3y square as the term. So after integration is with respect to x. So 6y raised to 4 is constant. Integration of x is x square by 2. 2y cube is constant, and integration of constant is constant into variable. So 2y cube is constant because integration is with respect to x. So 2y cube integration is 2y cube into x plus 3 integration of y square is y cube by 3 is equal to constant. So after simplification, we have this is the general solution of the given differential equation. Again, the same type problem, find integrating factor and solve the differential equation. So m is this, n is this, find dab m by dab y, dab n by dab x, both are not same. Then this ratio is 1, denoted by is independent of x, denoted by qy. So integration of qy, that is 1 dy is y. So e raised to y is the integrating factor. Multiplying by integrating factor, we have this, which is the exact differential equation. So its solution is integration m dx plus terms in m, independent of x dy is equal to constant. So write m, write terms in n independent of x is this, y e raised to y. And then here e raised to y cos y is constant, and integration of cos x, just we find integration of cos x because integration is with respect to x, dx means integration is with respect to x, means e raised to y cos y as constant. So take outside the integration, that two terms, we have integration cos x dx plus here we have to use the part rule, y into e raised to y dy. And so cos x integration is sin x plus integration by part rule. First second integration of first into second is what? First integration of second minus integration of second derivative of first. So first is y, e raised to y is exponential function. So use the rule LIAT, light word, to indicate the number. So this is first, this is second. Y is algebraic function and e raised to y is exponential function. So first integration of second, e raised to y, integration is itself e raised to y minus integration of second. So e raised to y integration e raised to y, derivative of first, derivative of y is 1 with respect to y, dy is equal to constant. And then e raised to y, just write e raised to integration of e raised to y is e raised to y. And so this is, if you take e raised to y as common, we have this bracket, and this is the general solution of the given differential equation. Again, the same type problem, find the integrating factor and solve them. So write m, n, then find dab m by dab y, dab n by dab x, both are not same though. So the given differential equation is not exact. Then find this ratio as minus 2 by x, and this is independent of y, purely function of x. So it denoted by fx or qx, and then px or qx or fx, and then find it integration of fx as a minus 2 log x, means log x square, and then integrating factor is e raised to log x square, x raised to minus 2, log e raised to log x raised to minus 2, and that is log and e get cancelled. So x raised to minus 2 is an integrating factor. So multiplying by x raised to minus 2, we have this, and then its general solution is by using this formula. So we just integrate this, y cube is constant, x square x cube by 3, and then 1 by x square. What is the how you can find 1 by x square? 1 by x square means x raised to minus 2, and by using the rule x raised to n, x raised to minus 2 plus 1 divided by minus 2 plus 1, that is x raised to minus 1 divided by minus 1 means minus 1 by x is the integration. So this is the general solution. So these are the problems for homework. Again, the same type, that is determine whether the following differential equation is exact, determine the whether the exact, if it is not exact, find integrating factor and then solve. So solutions are given. So I had to find the integrating factor and then solve the given differential equation. So first find integrating factor. So first check whether the given differential equation is exact. If it is exact, then solve it. But if it is not exact, then find integrating factor. So answers are given. And to find the integrating factor, we have to use one appropriate method out of the 6 methods to obtain the integrating factor. So solve all these problems. So this topic is again important for MCQ type. That is this is the given differential equation, and question is MCQ type question is determine whether this differential equation is exact or not exact. Okay, so which of the following is true? So either this differential equation is given and the question is which of the following is integrating factor. So by inspection method, y dx minus x dy is equal to 0. The integrating factor is 1 by x square or 1 by y square is the integrating factor. So solve all these problems. So in the second method, That is the method that differential equation reducible to the exact differential equation. This is the type, and in this type there are sub six methods. That is, find the integrating factor for the differential equation, and then solve the by multiplying the differential equation and solve the given differential equation. So all these problems are of that type. That is the type which depends on the type is the subtype of exact differential equation. That is the differential equation reducible to the exact differential equation. And how we can reduce the given differential equation to exact differential equation? By multiplying integrating factor, we have to reduce the given differential equation to exact differential equation. Suppose mu is the integrating factor of the differential equation m dx plus n dy is equal to 0, then multiplying by mu is an exact differential equation. So, and how we can find integrating factor? So there are 6 methods. This is the inspection method, and the remaining 5 methods are depend on these 5 rules. Rule number 1, rule number 2, rule number 3, rule number 4, and rule number 5. So this is about the type exact differential equation and differential equation reducible to the exact differential equation. So we will see the next type, linear differential equation, in the next